Hello, and welcome to the Computer Vault podcast, where we discuss the history of computers, computing, and IT, and where we uncover the amazing stories that shaped our modern digital world. I'm Aidan, and today we're diving into one of the foundational innovations in computing, magnetic core memory, and the brilliant mind behind it, J.W. Forrester. If you're listening on the day that this podcast comes out, which is Friday, February the 28th, 2025, on this date in 1956, J. Forrester patents the magnetic core memory. Picture a time when computers were enormous machines that filled entire rooms, requiring constant maintenance and dedicated spaces. Imagine you had to use huge, clunky devices that were not only cumbersome, but also limited in capacity. That's where J. Forrester comes in. His invention not only transformed how computers stored data, but it also paved the way for the rapid evolution of technology by establishing a new standard for memory efficiency and reliability. Stick with me as we explore the journey of this groundbreaking technology. Let's rewind the clock to the late 1940s and early 1950s, a period when computers were still in their infancy, predominantly used for military and scientific calculations. Prior to the development of magnetic core memory, computers relied on vacuum tubes and other fragile components that were not only bulky but also notoriously unreliable, demonstrating high failure rates in critical operations. The quest for a more durable and efficient memory system was critical not just for operational stability, but also for advancing the potential of computing technologies during this transformative era. J. Forrester, working at MIT's Lincoln Laboratory, was determined to solve these problems. In his own words, he once described his approach: I sought to create a memory system that combined reliability with speed, something that could preserve data no matter how intense the operational demands on a computer might be. This vision set him on the path to invent magnetic core memory. During these formative years, notable computer models like the Whirlwind were beginning to show that digital computing had enormous potential for applications ranging from military defense simulations to scientific research. For instance, Whirlwind's ability to perform real-time calculations set a precedent for future innovations. The engineers of the era were experimenting with various methods of data storage, and Forrester's work soon emerged as a turning point in computer design, eventually influencing commercial computers and paving the way for digital revolution. One thing to note is that magnetic core memory wasn't developed overnight. It was a series of experiments and refinements over several years. Inscribed within the details are specific milestones, such as enhanced reliability and scalability, that soon made it possible for computers to store more information and perform more complex calculations. Now, let's talk about how magnetic core memory actually works. But don't worry, I'll keep it simple and relatable. Imagine sewing a patchwork quilt which each patch represents a tiny magnetizable ring, or a core. Just like how each patch holds a piece of the overall picture, every magnetic core stores a small bit of data. When you send an electric current through these cores, it magnetizes them in one direction or the other, essentially flipping a tiny magnetic switch on or off, which corresponds to the binary states of 0 and 1. J. Forrester explained it quite clearly. Think of the cores as miniature compass needles. Just as a compass needle reliably points north or south, each core can hold a binary state, a 0 or 1. That tells the computer what to remember. This simple yet robust concept allowed for much faster and more reliable memory. In everyday terms, if you consider your modern smartphone, you're familiar with how quickly it can recall your favorite apps or contacts. Magnetic core memory was an early step towards that kind of swift information retrieval. By breaking down the function into simple on-off states, Forrester's memory made it easier for computer systems to process data in a way that was both intuitive and dependable. Additionally, the technology featured impressive scalability. Early computer systems might have a few thousand bits of memory, but with core memory advancing, models in the 1960s could support memory capacities that were leaps and bounds greater. This evolution in storage capacity set the stage for the modern computing landscape. So, why is magnetic core memory so important? Beyond its clever design, its impact on the computing industry is undeniable. Before magnetic cores, computer memory was not only fragile, but also inconsistent in performance. With Forrester's innovation came a robust and dependable method of storing data that laid the groundwork for the computers we use today. Companies like IBM swiftly recognized the immense value of this innovation. For instance, the IBM 703 family was one of the first to integrate magnetic core memory into their systems, leading to dramatic improvements in reliability and speed that set future industry standards. This effectively fueled the growth of the mainframe computer era in the 1960s, where memory capacities leapt from a few thousand bits to tens of thousands and eventually millions of bits, enabling larger scale computations previously deemed impossible. J. Forrester's work also indirectly accelerated developments in software. Faster, reliable memory meant programmers could write more complex code while relying on the hardware to perform consistently. As a result, research, military computing, and commercial applications all flourished under this new system. In reflecting on this revolutionary period, Forrester once remarked the magnetic core was not just a piece of hardware, it was a building block for a new era of computing, enabling machines to think and remember more like humans, but at speeds and scales previously unimagined. His words encapsulate the profound influence his invention had on the course of technology, as it radically changed how data was processed and opened doors to future innovations. As I wrap up today's episode, let's take a moment to appreciate J. Forrester's pioneering work. His development of magnetic core memory turned out to be a critical turning point that helped transition computers from unreliable room-side machines to more efficient, scalable systems. It laid the cornerstone for subsequent advancements in memory technology, from early mainframe computers to the microprocessors in today's digital devices. Whether you're a seasoned tech enthusiast or just curious about where modern computing started, the story of magnetic core memory is a powerful reminder that innovation often begins with a simple idea executed brilliantly. Forrester's vision and determination serves as an inspiration for all future inventors. Thanks for tuning into the Computer Vault podcast. I hope you enjoyed this trip back in time and gained a deeper understanding of how magnetic core memory changed the face of computing. If you enjoyed the show, please rate and review on whichever platform you're listening on. You can also check out my website at www.computervault.co.uk, where you'll find previous blog posts from the podcast episodes and details of my collection, which includes a variety of books, manuals, CD-ROMs, floppy disks, magazines, cassette tapes, and even some old retro computers too. Until next time, leaving you with a quote from Alice Kahn: "For a list of all the ways technology has failed to improve the quality of life, please press 3.